What I wanted to talk about tonight was some of the surprises that we've stumbled upon over the last 20 years that I've been here. Science really is about discovery and surprises and finding things and coming to grips with things that you didn't expect. And often, when you find them, you're really surprised, and sometimes you don't even believe it. And I would say in many cases with this research I'll talk about, you make some discovery, you look at the data, and you say, that can't be. Well, that's when it gets really exciting, because you're starting to change the way you think about the world. The first one was that invasive species are actually, and when I say invasive species, I mean in lakes, in inland waters, in Wisconsin and this sort of surrounding region. Invasive species are far more widespread than we think. If we go look at the records of invasive species that's maintained by the GNR, and you take the 5 or 6 invasive species that we commonly focus on, like Eurasian water milfoil and zebra mussel, blah, 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 and you say how many lakes in Wisconsin contain a record of an invasive species, it ends up being that about 7% of the lakes in Wisconsin have an invasive. Okay. But here's the thing. Now, imagine you have a field crew, you pull some students together, you go to a bunch of lakes in Vilas and Oneida County, or maybe all around the state, and you are going to sample these lakes and look really hard and see if you can find invasive species. Well, when we go out and do that, we find invasive species in about 75% of the lakes that we sample. So when you use the power of statistics and do a weighting process, and you do the math, essentially what you come up with is that about 40% of the lakes in Wisconsin contain one or more species of invasives. So it's not 7%, it's not 75%, it's somewhere in the middle, and our best estimate from how invaded are the lakes of Wisconsin, it's about 40%. So we're way more invaded than we think we are, although it's not 75% either. All right, so item number 2 is a small one, and it stems from the first one. And item number 2 is that the remote, undeveloped lakes in Wisconsin generally don't have invasive species. This is something that we were sort of intrigued by because, people have often been saying, well, invasive species aren't moved around by people. They're moved around by ducks, and there are natural processes for these species to move around. So we had a survey, one of my graduate students about 6 years ago, Alex Slotska, was trying to get out to get some of these really remote, difficult-to-sample lakes. So he was able to get into 11 lakes that were just really hard to get to. And in those 11 lakes, he found no evidence of any invasive species, despite the fact that he's really good at finding them. From what we know in Wisconsin right now, these remote systems are protected from the impacts of invasives. And it highlights the fact that humans are the major driver for the spread of these species. And my final point is that invasive species impacts are highly variable from place to place, but they can be enormous. The spiny water flea likes to feed on tiny crustaceans that swim around in the lake, particularly the species known as Daphnia. Now, Daphnia are a sort of inconsequential little crustacean. Very few people recognize that in many lakes they play an incredibly valuable role in that they eat algae and they do a really good job of clearing the water. So in many lakes that have algal overgrowth problems, Daphnia are helping to keep those algal blooms down. This was definitely the case in Lake Mendota, where you had really high densities of Daphnia in the system, and they were doing a great job keeping the algal blooms at bay. We really only knew what an amazing job they were doing when spiny water flea came in and wiped them out. Because what happened after this food web change happened, spiny water flea come in, wipe out Daphnia, was that the water clarity got way worse and the algal blooms came up. We lost about 1 meter of water clarity in Lake Mendota, and Lake Mendota is a eutrophic green lake. It didn't have that much to lose in the first place. So algal blooms got worse, the lake got way murkier. And that was all triggered by this invasive species that came in and disrupted the ecosystem. So we were thinking, wow, all right, it made this huge change. We lost all this water clarity. And we thought, well, how can we put this into terms that people might relate to and policymakers might wake up to and realize, hey, this is a big deal. So we thought, well, how could we put a dollar value on the 1 meter of water clarity that we lost in Lake Mendota? And our approach was to say, well, if we wanted to regain that meter of water clarity, what we need to do? Well, we could reduce phosphorus loading. And so we calculated how much phosphorus loading we would need to reduce. And it ends up being that we would need to reduce phosphorus loading into Lake Mendota by about 70% just to get back to where we were before. And we know how much changes in land use practices and agriculture we would need to do in order to get there. And those practices would cost about $100 million. So essentially, it puts a price tag on that invasive species in Lake Mendota alone at approximately $100 million in terms of the losses of environmental services that we've gained. So it's just sort of an example of how we can kind of think about invasive species in creative ways, and it highlights the point that in some places they can have huge impacts. And it seems like every year there's a new invasive species coming onto the landscape. We're learning a lot about these species and what they do and how they spread, but there's still a tremendous amount to learn.
What are the main things that you need to do to keep your lake healthy?
There are several aspects of that. One is ensuring that there is sort of a complex natural habitat. So that would involve there being aquatic plants and coarse woody habitat for the sort of range of species that are there. I would say trying to have intact shorelines where you have natural vegetation along the shoreline, making sure that you don't have a lot of pollution coming into the lake. That could be road salt coming in from a nearby road, or it could be nutrients that would be coming in from a fertilized lawn. I just, think of the lake as the natural ecosystem and try to stay as close to that natural ecosystem state as you can, and that would be, I think, the best way to think about it.
The state of Wisconsin in 2017, the economic impact of tourism was $20.6 billion. And I'm going to guess that a large part of the tourism is lakes and trails and waterways. Is the state of Wisconsin doing anything to make sure we have healthy lakes?
That is a really great comment, and I think the more we can argue for the value of our lakes in as many dimensions as we can, the better. I mean, they're not only part of our lifestyle, but they have this economic value, they have spiritual value, they're part of what makes us who we are here in Wisconsin as cheeseheads. So I think that's an argument that we can and need to make again and again. Now, to answer your question, there are certainly people who are doing a lot. There are the people who work for the DNR, there are private citizens, there are people who recognize the value of lakes and also make these economic arguments. I mean, the state of Wisconsin should be, I'm not saying the individuals who work for the state, but the state itself should be doing more to recognize the value of our lakes, the value of healthy lakes, and protect them as these jewels that are just so fundamentally important to what we have here. I mean, people come from around the world to experience our natural resources here. And for us just to sort of not, make effort to protect them, it boggles my mind in a lot of ways. And so we should all just try to keep making this argument about how valuable our resources are and figuring out better ways to protect them. We know a lot of the things that we need to do, and there are also new things that we can figure out to do it better in the future.